The beauty of this pattern is how much simpler it makes it to base your data fetching on your URL directly and have entirely different components that fetch entirely different data based on the URL itself. B and C. But A needs to fetch data. Now, these don't get rendered until A's fetched its data, and B and C can't render until that data is fetched. But if A fetches the data that it needs, as well as the data B and C need, these can all render at once this data fetch comes through. Data fetching in React. I want to say it's complicated. It's optionally complicated. So what do I mean by that? What I mean is, if you want to get some data and not think too much about it, go to the React query docs now. Like, React query is great. For those that don't know React query, it's now TanStat query, which is awesome. Gonna go to the V3 docs, so I'm more familiar with them. TLDR with React query, it's a very easy way to do an asynchronous thing, either a fetch or a random stuff locally. You can use it to get data or to make a post to change data. It has two base primitives you use. Queries, which are used to basically, when this component renders, it runs the function you pass it, in this case a fetch that gets JSON. And then you have that in data when it's done fetching, and you have it, the is loading set to true when it's still loading. So these 3 lines of code that are only 3 lines of code because they're like broken out nice, like on new lines, fetches from GitHub, turns that into JSON, caches that in the React query cache layer, which we'll get to in a bit. But most importantly, it gives you these nice states ahead of time. A loading state for when it's loading, an error state for if anything goes wrong, like your network fails or the API doesn't or give you the response and errors out, all those types of things. But most importantly, it gives you the data, which is type safe to whatever you return here. So if I was to fetch.then here as user and shape that data with TypeScript, that shape will be correct here. Or if I fetch from a type safe API here, then we will get the data through the same way as well with type safety. It's the easiest way by far to do something asynchronous and get that data into your React code. The other important piece is mutations, which just Command K for mutations there. Cool. Mutations are more for actions rather than a thing that loads when the component mounts. It's more for you want to do a thing, you want to create a to-do. A user clicks a button and it goes and it does something. So from there, AXIOS.post in this case, we are posting a new to-do item when it's passed here. And now when you call mutation.mutate, whatever the typed expectations of that function are here. And if you don't do that, it will type error. And once you fire the mutation.mutate, you get back a bunch of other nice things, including the same data loading error stuff that we saw before. So I don't necessarily like how this example is broken out. I would have broken the mutation out into an is loading, a data, and a mutate, similar to how we saw before. But these primitives are so powerful and make it comically easy to write custom functions that do crazy asynchronous stuff, give you your data state, give you your loading states, give you type safety if you built a type system around it. It is generally the easiest way to fetch data and deal with asynchronous stuff on client. So if you're using React and you just want to get some data, you should probably be using React query. And if you're not, you should have a good reason. Here is where we start to talk about those reasons. So if you're just looking to go fetch some data and be done, honestly, and it's going to kill my metrics, you can stop watching the video now and go do that. That said, I think things are much more interesting than that, and there's a reason that we keep bringing up the data fetching topic. There are some things that I want to quickly say we won't be talking about much. The things we won't be talking about much. So these things are fetch. Hopefully y'all know how the JavaScript fetch API, I shouldn't say how it works, nobody really understands it, but at least know it exists and you can use it to fetch data and do anything. As such, we also won't be talking about AXIOS because there isn't really much reason to use it anymore. You should just use fetch, it's built into everything. We're also not going to be talking about use SWR because it doesn't do mutations. So it does data fetching in the loading sense, but it doesn't do too much else. It's a nice minimal way to fetch data, but it's not much smaller than React Query, and there are so many powerful things React Query does. Somebody said that SWR does do mutations. No, if they does, then that was a very, very recent change. They have the word mutation here, but this is for mutating a cache entity locally. This isn't for firing an asynchronous user-driven event because a user clicked a button and that posted something that has a data state. There is no real sense of mutation. They should not have used that word for this. It was dumb. They're adding mutations to use SWR eventually, but it's also worth noting that these docs haven't been updated. Oh, I guess this one got updated very recently, which is funny because last I checked, it had been like a year. So yeah, version 2 might have that. I'm not talking about it until it works and I've used it. It is just missing a lot of things that you need. So we're not talking about these things because if you're picking between them, go use fetch. If you need something for React, use React Query. But I want to talk about data fetching flows, patterns, and how different solutions are working and changing. So what we will be talking about is I'm just going to list the things. NextJS and Remix, data flows, SSG, SSR, caching, strategies. Most importantly, the one I know I don't have to talk about, but it just makes a lot of sense, is suspense and server streaming. Here's where things get a little more complex. So, when do you fetch your data? This is a more complex question than it may sound. Data fetching can happen at a lot of different points in the lifecycle of your application, but we should start with the first data that's requested by your application, the HTML. So let's say, I guess I need to draw a diagram here, make it an arrow. I'll do it the vertical way so we have the flow. So at the top here, we have user requesting a site. At the bottom here, we have fully loaded page. So from here, a lot of things have to happen. We'll start with the traditional, we'll call this I'm trying to think where I want to put the label for this because I'm going to have to draw a few of these depending on the different strategies. We'll call this the SPA strat. An SPA is a single page application. It usually means that there's one HTML file with almost no data in it, and then a JavaScript bundle that it loads that does everything from there. So the first step here would be server sends back mostly empty HTML with script tag for React. The next thing that happens is React or browser fetches that JS bundle and loads it. I should actually separate these because they're separate steps. JS bundle loads, or I shouldn't say loads, runs and creates the page with all the loading states, etc. I shouldn't say that for now. Creates the page with your React code. And then we have components. So some component needs data and requests that data. I have to get a lot longer. Data is returned to client. React updates DOM with that data. Cool. So here is the general flow. So what does the page look like at any one of these steps? Until this point, the page looks like this. So at first, the page is empty. There's nothing there. I'm just going to put text for these. So what you see during that section is a blank slash just white page up until this is parsed. We'll call this the like yellow section, which is the loading state. And then once that data is returned, we get to green, which is the actual content. So we have blank white page, loading boxes, or loading state placeholders, and then fully loaded page. So when you're using something like Create React App to do a traditional single page app, you can think of the flow kind of like this. You have the request at the top. You get back an empty HTML file. Theoretically, you could put some type of loading state in there, but it's not going to be the most accurate based on like your route, things like that, because the JavaScript has to figure out which page you're on and render things from there. So then you get the loading state that you'll see for most of this section here until all of the data has been fetched, and then you see the fully loaded page. This is assuming that all of the requests that the page needs are identified at once. This can actually get worse though. Let's sketch out a quick page. So we have here an empty page. And on this page, we have a top nav that has your like profile on it. This is like me. Oh, it's not, it shows you if you're signed in. It doesn't if you're not. I'll just kill that line, make it look like that for now. You have, we'll do the Twitch homepage. You have your sidebar. This is like your list of things that you follow. And then you have the carousel, which has content within it. And this guy has a profile pic as well. I'm also going to copy the profile pic and put like a bunch of those here. So each of these sections needs to fetch some data. What I'm going to draw now is an example. How do I put it? How these things would pop in a web app that's poorly architected and then one that's better architected using the single page app architecture. So when the page first loads, it'll probably have a loading state for a few of these different sections. So here, actually, I'll just draw this in as orange for loading. I'll do another box here of orange for loading as well. So this box loads in. And we also have to load in the contents here. So each of these would be a request. Like this one is get user current user. This one is get current user friends or get current user follows. And this one is get currently or get current carousel or get current homepage content. So all three of these requests are different, but they can all occur at the same time. So if these all occur at the same time, then once they've loaded in the next state, these are now green. But let's say the data you get back for this list is just the user IDs for all of the people you follow. It doesn't have their profile picture. It doesn't have any of the other info there. So now it knows it has to render however many of these profiles, but they have to load as well. So even though the background has now popped in, you have an orange loading layer there. You have an orange, you might even have an orange loading layer in the carousel for the box here because it knows which streams to render, but this one has to go get more data before it can render. After that, you might have another set or request that makes, or so now all of those requests come through. These have turned green. Your profile pictures and all the sub content in that component has rendered in. This might have as well, but this guy has a profile picture too. So now this profile picture is in a loading state that has to come in as well. So what you see here is like a pretty basic example that is common on most websites where this component here doesn't know what to render until it gets its data. It gets its data, it renders children, but now those children also have to fetch additional data. It's a pretty common problem where if I had like each of these subcomponents has its own use query or use SWR or its own effect data fetch, whatever. If these need data that isn't included in this first request, then you've now done what's called a waterfall, where the data has to go through that first layer, render those components just to identify which data to fetch next. So the loading spinner hell that we've all seen on many a site before, where there's one big loading spinner, then a bunch of smaller loading spinners, then a bunch of even smaller loading spinners, then one breaks but two others load, and then the data slowly starts coming through. This is why. Because on this first state, 3 requests are made for here, here, and here. Then on this state, 3 requests are made for here, here, and here, and these can come through in different orders. No one knows what's going to come back when, and then this additional request needs to be made after that. Ideally, when you're fetching data, you get all the data you need on that first request. So instead of use data for A, use data for B, use data for C, and then use data for A ID1, use data for A ID2, you would have one big data fetch called here that gets all of the data it and its children need. You have one big fetch here that gets all the data it and its children need. You have one big data fetch here that gets it and all of the data its children need. But this is a page, so you can get the data for the whole page at once, ideally. This lets you significantly reduce the amount of time you spend in the placeholders loading hell if you are able to fetch all of your data in like one pass. Not the easiest thing, but again, this is for when you're trying to get the best possible performance. Try to pull all of your data fetches up early enough in your component hierarchy that you get back all of the data you need as early as possible, rather than having subcomponents determine which data they load. So like the mistake here, if I was to draw this as a component diagram, we have like the app, we have like child A and B here. We'll say both of these need data, but this doesn't render these until it has the data it needs. So we'll say like this is, oh wow, that's tiny, B and C, but A needs to fetch data. Now these don't get rendered until A's fetched its data, and B and C can't render until that data is fetched. But if A fetches the data that it needs as well as the data B and C need, these can all render at once this data fetch comes through. So make sure when you're thinking about your data fetching that you're also thinking about when that component renders and if other components need data that have to render first before that subcomponent renders. Ideally, the parent would fetch the data all of these need. So one way you could do this is, let's say this has a hook like use data for A. And this hook fetches the data that A needs. I think there's even a code. Cool. So we have use data for A. So this fetches use data for A. And then after that data fetches, this calls use data for B. And this calls use data for C. If these don't require a property that comes from use data for A, ideally, you would just call all 3 of these here and pass the props down to B and C so that they can all be called at once. But if these both have data that comes from A as like their inputs, then things get a little more complex. Now we need a way to, based on the data we got here, get additional data that these need. What this usually means is you need a backend engineer to make a change to your API, or if you're using something like TRPC or Next and building your own backend stuff, you can do the additional data there. So, or fetching there. So if this guy returns a data structure, that's something like, we'll call this A:, B, ID, C ID. So this is what we get back here. And we need BID to do this fetch, and we need CID to do this fetch, but we need to get those values off of this. We don't have this data yet, so we can't just batch that on client because we don't know what B and C are going to be when this comes back. So what we would want instead, I should structure what we expect back here. We'll say B is, we'll say it's your friends list, which is an array. And we'll say that C here is your settings, which is a JSON blob. But we need to have the input to get these. What the ideal would be is A, instead of returning the IDs that then these have to fetch from, is this guy just immediately returns the friends array, and C immediately returns the settings JSON. And by getting the data that these need in use data for A, you can pass the data for B and C down directly, and everything comes back at once. So if you're fetching via SQL and you use this ID here to do a different SQL query, do the join in this initial fetch. If you have some chaotic data store somewhere else that is fetching this JSON blob externally, maybe do that in this API, maybe eat the second loading state here. But think about how your data is architected. Talk with the engineers who are working on it if they're not you. Figure out why there are different calls for these things, and then do your best to make those calls as early as possible so you don't have waterfalls causing sub parts of your user interface to render later and loading spinner hell. Or use GraphQL. Yeah, if the GraphQL API is constructed correctly, it works well for this because of the graph nature. That said, I have seen plenty of GraphQL projects where they don't call all of the data they need at the top with the first GraphQL hook. And I've seen some of the worst waterfall I've ever seen in GraphQL because it's so easy to write a quick like GraphQL like data fetch anywhere because of the nature of the custom hooks. The only way you can get around that with GraphQL is using a compiler that squashes everything into one query, like Relay, and I've never seen anybody other than like Jane Wong using Relay correctly, and the amount of insane code she had to write to make that viable was chaotic to watch. So yes, GraphQL can help solve this problem, but you still have to use it right, like very right to do that. But you gotta do that. Cool. So this is all single page app land. How can we improve further from here? By breaking out of single page apps. Right now, all of these examples are assuming that the page has to render first. So we're blocking for that whole window there. You see nothing. Then the loading states come in after the JavaScript parses. Then you start to get the actual content back or in on the screen. That sucks. I think we can do better. So how can we do better? So a new section here. Instead of SPA, we'll call this, we'll do NextJS the right way for now. A user requests the site. They get a blank page. I should actually do this side first. Ignore the colors here for now because they're going to be inaccurate until after I'll just move these over for, that's the whole thing. Oops. Yeah, we'll ignore the colors for now. First step, user requests the site. So now, assuming this page is SSR'd, I'll do NextJS SSR instead of NextJS the right way. I'll do NextJS SSR because this isn't necessarily the right way, and we'll show why in a bit. So NextJS SSR, server parses request and generates and runs React, I should say, and runs getServerSideProps based on route. So if your page has a getServerSideProps, that gets run first. Then once it has that data, it runs the React code on server to generate HTML for user. So this looks longer than the other part because I wrote more data here. I'm just gonna kill one line there to help that a bit. But these two steps happen. And then that HTML gets sent to the user. So HTML sent to user. At this point, depending on if you're doing data fetching or not on the client, no loading states. You're done. God, why is that error being so dumb? And that's it. The SSR here makes sure that you would actually kind of get a blank page for longer because that blank page is all of the requests that happen later. So we've basically taken this yellow section from before and moved it. Did not come with me. Cool. And we've basically taken this yellow chunk from before that happened way lower. Ideally, we put all of the data we need in one request. So this gets made smaller and it gets moved up in here. So instead of a loading state, you get this happens on our servers instead, effectively in parallel. That's a good way to draw it out. So this happens here where the user can't see it and HTML comes back to the user fully loaded. The catch here, and there is definitely a catch, is that the user sees nothing because you don't get any bytes back until this happens. So if we were to go compare two sites quick, one that's an SPA and one that is using NextJS SSR, we'll compare the SPA quick, which is Twitch. So if I go to the network tab here, you'll see, should probably do this in an incog tab. I don't care enough. You'll see that even if I slow the network down to pretty slow and do a hard refresh, you get something back almost immediately because this HTML comes back in like milliseconds. 2.83 seconds for the whole thing, but like 27 milliseconds for the index.js. All of these files come in really quick, and we get that first HTML back really quick because it makes the page show something. This is a loading state, so we don't have content yet, but at least we know the page is trying to load right now. If I was to do the same thing on Zapdos right now with the slow 3G, you see we get nothing for a bit. And then the data comes through. That's because the server has to do that first, generate the data before we get something back. But on a slow connection like that, it's barely an impact because the server's the one doing all that fetching, not the client. However, if I stop doing the slow 3G and I go back to no throttle, you'll see this has a page come up almost immediately when I hard refresh, whereas this takes a bit. There was a long loading state there, and it's still loading, actually. Okay, I still have it in slow 3G. I turn off the slow 3G, and I hard refresh it. There's actually a longer window where you don't get back anything. It's a little faster now because the Lambda is warm. But on a cold start where like Vercel has to spin up the infra, it's 104 milliseconds, whereas on Twitch it's 37. That's because my server is blocking the first byte. There is no response back on my server until we have done the data loading that I'm doing on server. With Twitch, there's an HTML file, and this file is super boring. It has some like metadata for like headers and such. Has a super minimal JavaScript thing to like do some basic like web vital type tracking stuff. And then it has an almost empty HTML with a tiny bit of styling to give that like shell experience early during the loading state. And then there's literally like 3 HTML elements on it. Okay, like 5. Shell nav and shell loader. And that's all of the HTML you get back from Twitch when it loads. The reason they do that is you get something on the screen immediately, and then the client goes to fetch whatever data it needs from there. Whereas on here, we load a page that actually has data in it, where we have the components, copy embed URL, like the header's actually inside of here. But they don't get anything at all until that data's loaded in. That said, I didn't load all of the data in here. There is data that comes through after. So we do the first request, and then the questions are requested separately here. You can see the result there. And this comes through after because I don't render this until it's on client due to a lot of like design decisions I made, mostly to show off TRPC and also to make this a dynamic request that you fetch from server. You would be able to, in something like TRPC with React Query, pass initial data from the getServerSideProps, but the architecture for that kind of sucks. So what we're going to talk about next is what if getting that data into your app in such a way that you could dynamically update it in the future, what if that didn't suck? I'm going to tell you now, it only kind of sucks right now because Remix does this pretty well. So how does Remix handle all of this? We'll move this out of the way for now as we go through the order of events for Remix. So server parses request and runs route loaders for path. Then it runs the React code. Then it sends the HTML to the user. It looks pretty similar. In fact, I think most of that's going to go to pretty much the same places. Yeah. So why is this better? What is it about this that I am excitedly saying is better? Specifically that this doesn't necessarily happen in one big blob. You could even see this as like 3 separate blobs running in parallel for each thing. And these all are different requests that different components needed. Whereas in here, you have to, in your get server side props, put all of the data everything needs there and then push that all down. There's only one place in Next where you fetch data, and that one place is at the very high level get server side props, or you go fetch data in your components yourself. Whereas with Remix, you actually get to do all of these fetches and all of this data loading in parallel for different components on a per component level. So if different pages have different routes, I suppose, have different subcomponents, those subcomponents can request their own specific data. So if I have a path, let's say /dashboard /user /some user ID /friends. It's like an internal dashboard URL. And each of these parts has data it needs. So I'll say that dashboard needs, I'm just going to copy all the arrows quick now. So we'll say that dashboard needs, I'll just do /API/dash. So this needs to hit data from here. Actually, I think it'll be easier to shape the data. So this needs, God damn it. Say that this needs role admin or user. I should have split this up in an easier way. Make these smaller. Actually, I'm going to break this up differently. So we have the dashboard user, some user ID friends. We're going to break this up horizontally. So you have the /dashboard /user /some user ID /friends. And y'all can see how I went from here to here. Or this is the URL. And this is like how you break that down into parts. Now, each of these parts can request its own data. This one requests role, admin, or user. This one is like all users. Say it's a user array. So like when you're on this page, it just shows the user. So when you load it, it has all of them. But then the sum user is a sub page, which is like user data. I'll say it's like a user JSON blob. And then friends is data that is specific to that user. So this is user friend data. So it's a user JSON array. So each of these things is data that you need. And I'll do this the NextJS way above quick. So if all of these are fetches, and let's say this one we have to fetch dash data user our current user ID. So as we fetch with the current user ID, this is fetch admin user list. We don't need to pass it anything. I guess this will also pass a current user ID so that it fails if the user isn't an admin. Then we want to fetch, actually, I'm not going to do that because we don't want to do that for the sub requests. So we'll just assume that there's a cookie checking auth for those. Then fetch user by ID. This takes a specific user's ID. I'll call that some user ID because we're using. And we have this friends section. Fetch users friends. So in Next.js, in order to do this the right way, we would have to have a get server side props const role equals const fetch admin or const user list equals fetch admin user list const user data equals fetch user by ID. Where does that ID come from? Oh boy, here's where things start getting fun. Const query equals request.query const some user ID equals query some user ID if know some user ID, return not found, true. And we now have that ID for sure. Yeah, I need to promise all these. I'm going to be lazy. Assume that I did that. Actually, I'm just going to do this the right way. Const p's or promises equals fetch user friends, some user ID. Cool. So now we have an array with all the promises fetching all our data. And at the end here, I'll const, that's dash data, user list, user info, and user friends equals promise.all settled promises. And we return props dash data, user list, user info, user friends. So this is how we would write the get server side props for dashboard user some ID users or some user ID friends. Cool. So that's bad, but not the worst, right? I'll put that for here. What if I want to just get the data for this page? Well, I got to rewrite the whole goddamn function. And in here, got to remove this one key. I forgot one close bracket. And for every one of those pages and subpages, you have to define the function that gets all of the data the whole route needs. So you're basically writing for each subpath that could exist on your route, all of the things that all of the layers need. Not great. I say regularly that get server side props is an anti-pattern. This is one of the biggest reasons why. It fails to understand how applications are structured. Because of this, NextJS is entirely redoing their data layers and overhauling them, which is exciting. It is a very needed change with the NextJS layout RFC. But they have not proposed what the new data architecture is going to look like at all. They are just promising to do it as part of the layout overhaul. So we are not there yet. Get server side props is an awful pattern right now for these reasons. So how do we do this in Remix? Because that's the thing I was promising was less bad. So I'm going to yoink these function names. Well, let's do the slash dashboard page first. So slash dashboard. This guy has a const export const loader equals async. Actually, I can just say, oh wait, no, we don't have the user ID. Async request return. Oh wait, I think there's a JSON wrap it in Remix. Fetch data fetch dash data request. I'll just pretend I've authorized this. Yeah, I'll assume that there's like an auth context that just gives me an ID here. I'm sure there's elegant enough ways to do that. I don't do enough Remix to know. Oh, I don't need to do the await there. I need to do the await here. Now you don't need JSON. That's cool. Nice. So here's how you get that data on the dashboard. And this would have like export const dashboard equals const data equals use loader data. And now you have the data for this subcomponent. And we'll say that this returns div. But the important thing is it returns a subroute of what is the next route is slash users path equals slash. I don't know how the subrouting works. I haven't done enough Remix to be sure, but we'll say this is slash users outlet. Okay, cool. We're using outlet. Cool. And now this very simple component will render whatever we put here, have the data this page needs. And if you have a sub URL, that will appear in the outlet for this. So if I copy, paste it, slash dashboard slash users, all this guy has to do is fetch admin user list, which we chose to not have anything there. We name this to admin user list. Use loader data, does whatever it needs to, has an outlet. And I want to be clear, I didn't define the component on this, so don't compare the length, because the length here is just the 3 lines there, just the 3 lines here, compared to the whole thing. I'm just trying to highlight how the data loading on the server is based on the routes themselves. So then the next subroute /users /some user ID. This would have to parse off the request somehow. I'm sure that there is a helper in Remix of like get path from route or something. And again, I don't use enough Remix to know the correct way off the top of my head. Const user ID. I'll name it correct. Some user ID. And in here, we request not the fetch admin list, but the fetch user by ID. Same deal. Y'all understand. It's per component as you nest, you fetch the different data then. But what Remix does from there is magic, because when you look at this and you think in terms of what we discussed before with React Query, it's like, okay, the dashboard loads, it fetches its data, then it renders its outlet, which loads the users, which then fetches its data, that renders its outlet, which then fetches this. So you think, oh, these are just happening in a waterfall again, right? Nope. That's the magic of Remix I was discussing here. Since it gets all of the things it needs from the request itself, it doesn't need to batch. It doesn't need to do any magic here to call and get all the data it needs at once. You don't have to go out of your way to manually batch it. It uses the URL to figure out what each of these data loaders needs, and then it runs them in parallel all at once. So all of these happen at the same time because the data that's needed for all of them comes from this first request at the top. That is the thing that NextJS does not enable at all. And this is the pattern that makes people love Remix so much, is that the data fetching is a direct consequence of the initial request in the URL itself, rather than it being tied to the component hierarchy and each page having its own chaotic data fetching like there. The beauty of this pattern is how much simpler it makes it to base your data fetching on your URL directly and have entirely different components that fetch entirely different data based on the URL itself. It's a cool pattern. It makes a ton of sense for pages that have, or websites that have lots of nested components, lots of nested user interfaces based on the URLs. Like depending on how many slashes deep your URL goes, this might be the only viable pattern to build the thing you're building. It is so much more convenient for those things. But for more app-like things where you don't go more than 3 layers deep and you're pretty like vertically low on the number of pages because you only have a couple different routes, honestly, something like Ping, where there just aren't a lot of routes and you spend comical amounts of time on the routes, this is less useful. But for like an e-commerce site that has like a components page or a chat section, stuff like that, this pattern makes a ton of sense. Cool. So ready to have a wrench thrown into all of this? We're going to talk about streaming. Streaming gets complex. Once again, I'm going to move these all out of the way for now as we do like the ordering. So, okay, my pinch to zoom isn't working anymore. Okay. Server parses request and runs route loaders for path. Sure, we'll say the same for now. Let's assume that like we're doing React streaming properly with Next or Remix. I don't want to be opinionated because like the React streaming solutions are in a crazy chaotic state right now and none of them work. But in the future where they do, it should look something like what I'm describing here. So we run the React code on the server. So, okay, so first we make the request, the server parses the request and identifies loaders, runs the React code without data, sends back HTML while fetching data, HTML skeleton sent to user. And here's where things get really weird. Why is this being weird? Excel is screwing itself right now. So HTML skeleton gets sent to user, and then more data comes through or more data is streamed through as server gets it. So this is going to really complexify this thing, because now we're going to get a loading state on the user's end again. So I need to bring back the orange for a little bit, and then the green at the end. So what's happening here is when this request initially comes through, this data is being fetched, but it all happens in the background, and these pieces get streamed in to the page after. So the data that comes down the wire initially is not all of the data that you needed. It is a loading state, but the rest of the data can be fetched by the server at the same time as HTML is sent to the client. So it's almost like here you're splitting up and doing two things. One is sending HTML to the user as fast as possible, and one is getting the data that's needed to finish the HTML so that you can send that to the user after it's gotten that HTML. So this solves the time to first byte problem of SSR, which is the user gets no data until all of the requests have happened, as we saw here with this chunk that blocks, or here with all of them running in parallel. We have this streaming going through such that you get to send HTML to the user way earlier, and then the rest comes through after. This is the perfect solution, so to speak, where we get the best of both. We get HTML to the user as quick as possible, and we get the data fetching on the server in parallel upon request. So if you were to break this down to like steps, and then we compare how things happen. I'm trying to think of how to visualize this because it's going to fucking suck. This is going to be like a generic version where there are three states the user sees: requesting, white screen, loading, placeholders, and fully loaded, no placeholders, full page. I'm not doing it, fully loaded page. So these are the three states that a user sees. We'll do like the SPA. I'm going to draw the three, or a line, and do it this way, and then number these 1, 2, 3 to make it easier to visualize. I can't tell, I'm struggling to show you or think of how to show this. So with an SPA, I'll label it. Step 1, obviously, I guess step 1 happens at the same time for all of them. I'm going to visualize this with the colors. I liked that. So the red chunk will be tiny, tiny. The orange chunk will be relatively long. And then the green chunk at the end. I'm going to delete that. So here is like an SPA pattern where the red is the white screen request loading. Orange is all of the states you see as data starts to come through, because this is a waterfall. There will be different like loading states throughout this, probably depending on how well you handle your waterfalls. And then the green here at the end is the final state. If we take a look at how this compares to SSR, this red section is going to get a lot longer. Not quite as long as the previous stuff, because we can start fetching the data here as soon as the request comes through. We don't have to wait, because I also want to put a line for when the data fetch starts. The data fetch probably starts around here. Do I do two different colors? No, because this is like what the user sees, so I'm not going to do that for now. This will make it nice and simple. So we need to lob off some of this time, because we don't have to wait for the client to parse the data and parse the JS and run it before we can start fetching more data. So depending on how slow the user's device is and how long it takes for that JS to load, this could be really far down or really high up, but only the chunk after that line is the chunk that gets added to the SSR time. That said, you get shit during this window. You just have a white screen. So although this does load faster and you don't get a loading state, the page feels slower because it's blocking for all of that time. Streaming is going to be more like this one. So we'll copy this for streaming. So with streaming, that same data chunk can start being requested early. So during that same window, we'll have a loading state. Just say it'll take a little longer because your server code does have to run and like parse what that is needed there, which would be the case for the SSR as well, but this will be just as far there. So this is like the difference for what the user sees between the three. In SPA, you get a loading state way earlier, but it takes longer for the official content to come in, and there's a lot of pop-in during this window. With SSR, you block until all of the data's in, so you get nothing until the data's in, but once it is, you don't have a loading state, you just immediately have things pop in. And with streaming through SSR, we block a little longer than the SPA because we don't have a cached HTML thing the user can use. We are still generating that first pass of HTML on the server. But while that's generating, we're able to run additional things in the background in parallel so that the user can see that first byte early and have the full page data come through without it being slower. So, any immediate questions about this? I hope that this clarifies long-term how data fetching is going to be changing in React, because we'll have to re-architect our applications a little bit so that we're thinking more in depth about when we fetch our data based on which components need it. And yeah, it's a fun thing. Someone asked in chat, are we going to be building with any of these? No, I don't code on stream anymore. We've been over this. Is the scenario in streaming just SSR with pop-in? Yeah, if you want to describe it that way. But you have to decide, like, do you prefer having a loading state or do you prefer having an empty page? Like, not when I say empty page, I mean a literal white screen. It's also just like, I don't know why nobody talks about these things like as an overview for all of them, because they're all like I've seen a lot of people talk about streaming. I've seen a lot of people talk about remix. I've never seen somebody compare the different ways to do data fetching and how they are different in terms of what the user sees specifically. There was so much other stuff I could go dive into there, but I really wanted to focus on the comparison for how the user is affected by these different solutions. Yeah. Static props and ISR, cool. I could have talked about these things. I probably should have. ISR is a nice hack because it lets you cache a static version of a page. Hope that helps you better understand the way that data can be fetched and parsed and accessed by your components in React, most in particular, how the different data fetching strategies affect what the user sees on their side. I think it's important to understand when you make those decisions, how those things are affected. All that said, if you're using React, you're not using React Query, probably should just go do that. If you have really strong desires to make the perfect data fetching patterns, hope this helps with your understanding of those as well. Make sure you're subscribed if you're not. Less than half of y'all are. Appreciate it. Also, thanks to Idez for the edit as always.